Precalculus, Unit 1, Day 3. Notes coming up. All right, we're going to begin by looking at the concept of increasing, decreasing, and constant functions. So if you remember back in Algebra 1 when we did slopes, okay, positive slopes and negative slopes and zero slopes. Positive slopes from left to right were increasing. Okay? If you remember puff, puff, positive and nice negative. If you don't remember, here's a little jog of the memory. Again, we're always going left to right. So from left to right, you remember going up, rising left to the right was a positive slope, puff, puff, positive. And then falling left to right, you remember a negative slope. And the skier here is happy that he doesn't have to, put forth any energy. He can just enjoy gravity pulling him down. It's nice. So there's a negative slope. And then the constant part, well, it takes a little bit of work to ski horizontally. So it was zero fun. So with slopes of lines, it was positive, negative, and zero. Now we're going to look at, in functions, increasing, decreasing, and constant. We're not going to worry about undefined because if we have a vertical section of the line or the function, then it's not a function. Okay. So here, again, we're looking at what used to be called a positive slope. We're just going to look at that as going from left to right. Our function, our y, is increasing. So over this interval, my y, or my f of x, is increasing. Over this interval, my y is not changing. My y coordinate is not changing. So my function, my f of x, is constant. And then this interval features my y going down left to right. It's decreasing. Okay, so it's what it looks like: increasing, constant, decreasing. Right, so always remember, you must go left to right. Okay? And so it talks about that here. Increasing, function is increasing on an interval, and only if a positive change occurs in x results in a positive change in y, or f of x. Okay, so notice that the interval where it is increasing, that's your x. If they say, what is the increase, or what is the value of your function, that's always your y, or your f of x. If your y, or your function, is decreasing, then whatever the x's are over that interval, that's your interval for the decreasing section of your function. And then your function is constant if the f of x does not change. So whatever the x's are, that's your interval of the constant function. Okay, let's scoot down and look at some examples here, shall we? So these three questions ask, it says, use the graph to estimate intervals to the nearest half a unit where the function is increasing, decreasing, or constant. So let's say we want to know where they're increasing. We'll do increasing first, and then for decreasing, we'll do decreasing second. And then any place that they are constant, we'll do that third. Okay, so looking at question 1, where is, from left to right, where is the y value, the f of x, increasing? Well, if I start here at negative infinity, it is never increasing. It is never increasing. So you can use the empty set. You can say it never increases, right? Where is it decreasing? This is always decreasing. If you look at this on a graphing calculator and you zoom in, you can see that this right here is actually not horizontal. okay? It just stops decreasing as quickly. It decreases slower, 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 and then it decreases really fast again, right? So it decreases the entire time. So what is the interval that number one is decreasing? It's all of it. It's from negative infinity to infinity. So when is it constant? As I said, this is not horizontal, okay? It is not zero fun from linear algebra. There is no interval where this one is constant. It's always decreasing from left to right. Okay, let's look at the second question here. Okay, so where are we increasing? Okay, so from the left to the right, we're increasing from here to here and from here to here. So there are two intervals where we're increasing. So starting from the left, okay, so starting from negative infinity, okay, we're going to the right and it's increasing, increasing, increasing. Okay, now where is it increasing? It's increasing from negative infinity up until negative 1, okay? The x coordinates define your interval. Don't forget that. The x coordinates define the interval. You want to write that down, okay? Do not write the y coordinates of the f of x for the interval, okay? Those are the values at any given point, but the x coordinates are your domain, your interval, okay? So from negative infinity to negative 1, we're increasing, okay? And then we're also increasing from here to infinity. So where is the here? That here looks like when x is positive 1. Okay, so remember, when I'm saying over what intervals or what parts of the domain is my function increasing, it's my x coordinates, So we're talking from positive 1 to infinity. Okay, put a union in it. So from here to here, increasing. What about decreasing? Well, I can see a decreasing part here. Absolutely. Let's stay with orange. Actually, no, let's switch it up here. For decreasing, this part right here, it's going down from left to right. So that's going from negative 1, my x, to positive 1, again, my x. So from negative 1 to 1, we are decreasing. Okay. And I would say it's pretty safe to look at this and see that there are no horizontal parts where we have a constant area. So there is no constant part of my function. Okay. Let's look at question 3. Question 3, let's look for increasing from left to right. From left to right, this is increasing. Okay, it's going up. So where is it going up from? That's not an arrow. Okay, that's not an arrow. So that's kind of important. It starts right here at negative 4. Okay, so from negative 4 to this point right here, and that's at negative 1. Again, we are only looking at the x coordinates for the domain or for the intervals, okay, the intervals of the domain. This part right here is increasing. The rest of it has no increasing. Okay, I think you can all probably see that this part is not decreasing. So there is no section of your function where we are decreasing. And then finally, where is it constant? Well, it's constant from this point to, again, there's no arrow. So from negative 1 to 3, it's constant. Okay, sweet. So there you have it, increasing, decreasing, and constant from looking at the graph. Okay, let's go to the next section. So the next topic that we're going to look at is maximum and minimum values, or we'll say maxima and minima for plurals. Relative versus absolute. Okay, relative means in a certain little interval, in a little area. Absolute means for the entire function. If I say something is a relative minimum, that means it's the minimum for a little teeny defined function, okay, a defined interval. So it could be the minimum in, let's see, this part of your graph. You can see there's a little minimum right there, because to the left and to the right, it's going up, which means it had to have been a minimum down there. Okay? But that's not the lowest point of your entire graph. This one is. Okay? So this is a relative minimum, because in this area, it's a min. Okay? It's a min. So I know that it's not the lowest because that right there is lower. Okay? Now, if this arrow goes down forever, then this is also a relative min, but not an absolute min. Okay? So if you're looking at just a little piece of your function, a little interval of your function, then you're looking at relative minima, or in this case, there's a relative maximum. Okay? Because in that little area right there, there's a max, but it's not the highest point on the graph. It's not the largest f of x. It's not the biggest y coordinate, because that one is. So this right here would be an absolute max. And that would be an absolute max. Let's look at these two little graphs right here. Right here, you have a quadratic. It's going up forever. So there is no global max. There's also no little bumps. So there's no little interval where you have a relative max. So what you have here is only one point that is an extreme, okay, an extrema. And that is a minimum. So this right here is a relative min. Okay, that's a relative min right there. Right here, this one starts down. Okay, it never has a relative min or a max, because if you look at, say, this point right here at the origin, okay, to the right, it's going up, to the left, it's going down, okay, which means it's not a minimum because it's not up to the left, up to the right, and it's not a maximum because it's not going down to the left or down to the right. So there are no extrema, okay, plural for extreme values, okay, in this particular graph. Right? Now it says use a graphing calculator to find the mins and maxes here. So let's do that with Desmos. Okay, I'm going to get that up. All right, so here is the same graph. You can see over here the f of x, okay, x to the fifth, or excuse me, g of x to the fifth minus 2x to the fourth minus 2x cubed plus 3x squared. So if we look at this graph, we can see some extrema. We can see some relative mins and relative maxes. Okay, so I see right here a little bump where this point right here, okay, to the left and to the right, it's going down. So that means it's a max, it's a peak, right? So we would say that this is a relative max. Why is it relative? Because look over here, there are definitely points that are higher. They have a larger y coordinate. They have a bigger f of x, right? So it's not an absolute max. It's only a max for this little area right here. So for this area, that's a maximum. If they say, what is the maximum? It's 2.02. If they say, where is the maximum? It's negative 0.958. Okay, rewind that and listen to me say that again a couple of times. Okay, where is it? The x coordinate. What is that maximum? The y coordinate, the f of x. Okay, you see that right here is another relative max. How do I know it's a relative max? Because there's plenty of points that are higher than that relative max. But I know it's a relative max because to the left and to the right of it, you're decreasing, okay? So because the y value goes down to the left and to the right, okay, you know that there's a peak, and therefore that peak is a relative max. So the peak has a value of 0.478, but that peak is located at x equals 0.659, right? Are there any relative mins here? Yes, I see some relative mins. Okay, this right here is a relative min. The origin, 0, 0. How do I know it's a relative min and not an absolute min? Because I see points below it. But in this little area, this little interval right here, 0, 0 is no question about it. It's a relative min. So the function's value is 0 here, and it's located at 0 because x and y are both 0. The other relative min I see is right here. This is a relative min of negative 4.191, and it's located at 1.899. Okay? Again, it's a relative min because there are there are points far below that y coordinate. As a matter of fact, it goes down to negative infinity and up to infinity. Okay? So that's max and min, relative max and relative min for this one. And if we were back on the very first page here, at the very beginning, and what we were looking at with increasing, decreasing, and constant, we would have, an increasing, a decreasing, an increasing, a decreasing, and another increasing. We'd have 3 intervals where from left to right, the function, the y coordinates are increasing, and then two intervals where we are decreasing. Go. All right, the final concepts that we're looking at involve rate of change. Okay, so we're going to have averages over a period of time. Okay, average rate of change, if you remember back in Algebra 1 said that average rate of change was slope. Okay, if you did word problems in Algebra 2, you heard it again. Average rate of change was the slope. If you're looking at a graph, average rate of change from one point to another point is the slope of the line that goes through it. There's nothing different than what we're doing right here. So the average rate of change, okay, between any 2 points on a graph is the slope of a straight line that goes through those 2 points, right? And remember, we had this formula, which happens to be on your wall, y2 minus y1, x2 minus x1. But because we don't always say y, we say f of x, they're going to give you this, f of x2 minus f of x1 over x2 minus x1. So that's basically the same thing. It's saying f of x number 2, or y number 2, minus f of x number 1, or y number 1, over x2 minus x1. Okay? So now they're saying, here's a quick little example. Find the average rate of change over an interval from 2 to 3 on this function f of x, okay? Now, don't make this difficult. It's a slope question. It is a slope question. So we just need x1, y1, and we need x2 and y2. Okay, once we have those, we're just going to substitute numbers into our slope formula. Okay, well, remember, intervals only deal with x values. Those are x's, so we can call 2 x1, and we can call 3 x number 2. Okay? We just need to know what are the f of x's when x is 2 or when x is 3. So all we're going to do is substitute those x's in. So we need a couple of ordered pairs. We know that the ordered pairs are going to begin with a 2 for the first point and a 3 for the second point. So how do we find the y coordinates? Well, we're going to take f of 2, because we said 2 is our first x. And we're going to simply substitute it in. So instead of x cubed, it's 2 cubed. Minus 2 times, not x squared, but 2 squared. Minus 3 times, not x, but 2, plus 2. Okay? So what is f of 2? Well, let's just evaluate this. 2 cubed is 8. 2 squared times 2 is another 8. So 8 minus 8 is 0. Minus 6 plus 2 gives you negative 4. Okay, so that means the first point is 2 comma negative 4. Our second point, remember, has the x coordinate of 3. So we have to find f of 3. F of 3, and do the same thing. I'm going to substitute it in for x. So 3 cubed minus 2 times 3 squared minus 3 times 3 plus 2. Okay, now let's evaluate. So what is f of 3? Okay, 3 cubed is 27. 3 squared times 2 is 18. So 27 minus 18 is 9. Minus 3 times 3, so minus 9 plus 2. That gives me a y coordinate, or an f of x, of 2. Okay. So, so the second point, the x2, y2, is going to be 3 for the x and 2 for the y. Okay. So here we go. x1, y1, x2, y2. We're going to substitute that straight into our slope formula, and we're going to get the slope, or the average average rate of change, is y2 minus y1, okay, over x2 minus x1. 2 minus negative 4 is 6. 3 minus 2 is 1. So that's 6 over 1, or just 6. Okay. And so we can put 6 over 1 if you'd like. Right, so the average rate of change over the interval from x is 2 to x is 3 is 6, or 6 units per given unit. All right. The very last question we have is asking you for average speed. Okay. Again, average. We're going to be talking slope again. So average speed. Okay. From where t of 1, which is 0, time 1 is 0, to time 2 at 4 seconds. So they're telling you, what is my t, or my x coordinate? So when x equals 0 to when x equals 4. That's where we're looking at. That's the interval that we're looking for the average speed, or the average rate of change. Okay. So it says here that the distance that a moving car is from a stoplight is given by the function s of t equals 20t to the 3/2 power. Nice. So write this a little bit bigger here. S of t equals 20t to the power of 3/2. Okay, so let's do that. Let's find out what the y coordinates are. We know the x's. Okay, we know the x's. So let's find out what y is, or what s of t is, when we use the 0 for the t, or the x coordinate. So S of 0. So at time 0, you've got 20 times 0 to the 2 or the 3/2 power. Well, 0 to the 3/2 power is still 0. Okay, you can put it in your calculator and check it. 0, okay, caret to the power of 3/2. So 20 times 0 is, let's get it right back here, S of 0 is 0. So that means we got the origin. So when x is 0, y is 0. What about when x is 4? When x is 4, we have what is S of 4? Ooh, big one. Okay, so 20 times 4 to the power of 3/2. Right, now we can go over how you can do this. This is not a difficult thing conceptually to do without a calculator, but if you did want to put that in a calculator, you could. Exponents first. We do PEMDAS or GEMS. What is 4 to the power of 3/2? Well, 4 to the 3rd power is 4 times 4 times 4. So that's 64. And then the 2 in the denominator means square root. So 4 to the 3/2 is the square root of 64. 4 to the 3/2 is 8. So that's 20 times 8, which is 160. So that means when x is 4, the y is 160. In this case, when t is 4, the S of t is 160. Okay, so I've got my ordered pairs. I'm going to erase my work on how I got the ordered pairs, and I'm going to finish this off by using my slope formula, my average rate of change formula to find the average speed. So I have, let's call this x1, y1, and x2, y2. So these are my 2 ordered pairs. So when the x coordinate is 0, y was 0. When it was x was 4, y is 160. So the slope or the average rate of change, in this case the average speed, is y2 minus y1 over x2 minus x1. Okay, so that's 160 over 4, which is 40. Okay, now what is this? It's feet over seconds. So it's 40 feet per second. There's your average rate of speed. Okay, that's it for those notes. See ya.